Good day, students. I hope everybody is doing great. Nice. Today, our main strands to main number, our substrands here is ratio and proportion. Under the ratio and proportion, what we are going to discuss today is how to find the missing number in the equal ratio. How to find the missing number in the equal ratio. Our lesson has been taken from the resource pack or the curriculum of the BS6. Strand number 1, substrand number 4, content standard 1, and we are basing on indicators 2. So with this indicator, you can also verify this lesson from the new curriculum, as I said it earlier on. Okay, good. Finding the missing number in the equal ratio. Our last lesson we did discuss about the ratio, and we said the ratio is the relationship between two quantities, which shows that one quantity is being greater than the other quantity. Ratio can also be used to compare two things of the same kind. Ratio can also be written in a fraction form. Again, ratio can also be written in a fraction form, and then ratio can also be break down into its simplest form. In order to find the missing number in the equal ratio, when we say ratios are equal, it means the two given ratios are the same. The values are the same. They might be a different digit, but when you break them into simplest form, you could see clearly that the values of the numbers will be the same. That means the other side of ratio must be equal to the other side of the other ratios here. There are two methods to find the missing number in the equal ratio, which include the extreme method and fraction method. The extreme method means multiply the nth ratio numbers and equate it by the multiplying middle ratio numbers to get your linear equation. Fraction methods means change the ratio to fraction and use cross multiplication to get your linear equation. The ratio is the relationship between two quantities, which shows that one quantity is being greater than the other. Ratio can be used to compare two quantities of the same kind. Ratio can also be break down into its simplest form. Ratios are always written in a fraction form. I said there are two methods that we can use to find the missing number in the equal ratio, which include the extreme method and fraction method. The extreme method means multiplying the nth numbers, the nth numbers or the nth ratio numbers, and equate it by a multiplying middle ratio numbers to get your linear equation. And if you don't want to use that method, you can also adopt the fraction method, whereby the ratios are being changed to fraction and use cross multiplication to get your linear equation. Good. Let's solve one more examples with the extreme and then the fraction method. Now, example. find the missing number in the ratio below. So we have two ratios here. They are two equal ratios. You are going to find the missing letter here. There's a number that has been placed with a letter. So you are going to find that particular number here. So the letter here is K, used to replace what? The missing number. Okay. So with this, let's write our solution here. Now, the first method that I'm going to use the extreme method. Okay. So with the extreme method, you stated the questions and then you reduce the other ratios into its simplest form if possible. Okay. So 6 to 9 equal K to 6. Now with the 6 to 9 can also be reduced. So here you find a common factor that can cancel 6 and at the same time can reduce 9. And I think 3 can do that. So 3 goes here. 2, and then 3 cancel this side. 3, then you have the other side, K 2, 6. Good. So always try as much as possible to reduce the other ratios to get the simplest form. The reason being that it will reduce the burden of multiplication. Okay. So if you reduce the other ratio side here, it will help you. So let me quickly multiply the extreme numbers. The extreme numbers are the nth numbers. You first multiply the extreme numbers, okay? And then you equate it by the multiplication of what? The middle numbers, okay? Good. So the extreme numbers here is 2 is 2 times 6. Then it must be equal to the middle numbers, the multiplication of the middle number, which is 3 times k. That is how the extreme method works. Always you multiply the nth number, the number that's at the nth, okay? And then you equate it by the number that's what? At the middle here. So here, when you multiply this one, 2 times 6, don't waste time to do the multiplication. Just put them in a bracket, okay? So 2 times 6 here in the bracket here is equal to, then 3k. Okay. When you reach here, you're supposed to find the k, not 3k. So you divide both sides by the number attached to the letter that you wanted to find. And you have seen that the 3 is attached to the letter here. And what you do to the other side must be done to the other side too here because of the equal sign. Okay. So you divide both sides here, this side and then this side, by the number attached to the letter that you wanted to find. Okay. So that the letter will be free. Now here will be 3 and here will be 3 here. Okay. So with this, I think 3 here will take care of 3 here so that the k will be free. Okay. Now, when we come to the other side, because of the multiplication between the 2 and 6, we can use the 3 here to cancel any one of the numbers here, but the 3 can only cancel the 6. Okay. So 3 goes here 1 and 3 cancels 6, 2. Good. Now with this, what is left in the bracket here is 2 times 2 in the bracket here all over 1 is equal to, this time k is free, equal to k. Now 2 times 2 is 4 over 1, which is equal to k. Good. And 4 over 1 is the same as 4. So 4 is equal to what? K. Okay. Or k is equal to 4. They are the same. Good. Now with this, you need to prove beyond doubts whether what you have done here is correct. So you have to do the substitution. That one might not be part of the question, but to double check what you have done, whether you have done the right thing. Okay. So we said 6, the question was said 6 to 9 equal to k to 6. Okay. Then this time we have found the k. So let's put the k, that 4 in place of the k, so that we will reduce the ratios and see whether the two ratios are the same. Now we have the 6 to 9 here must be equal to 4 to 6. Okay. These two ratios can also be broken down into its simplest form. Now you find a common number to cancel the 6 to 9, and that is 3. 3 goes here, 2, and then 3 goes here, 3. It must be equal to, then you have to reduce these ratios into its simplest form. You find a common number to cancel the 4 and at the same time the 6. So the number is 2. 2 goes here, 2, 2. Then 2 goes into 6, 3. Now it's obviously that the two ratios here are the same. Now we have 2 to 3 equal to 2 to 3. Good, we have done. The same question, let's try and use the fraction method. the fraction method, the ratios here is 6 to 9 equal to k to 6. Per our discussion, we said the fraction method, you must change the given ratios into a fraction, okay? So the 6 to 9, the fraction here will be 6 over 9, okay? Must be equal to, then you change the other ratios here into fraction, okay? Then here will be k over 6. Before you can do the cross multiplication to get your linear equation, then check the other fraction, whether it can also be cancelled or reduced to its simplest form. Now, looking at the first one here, we have the 6 over 9. You find a common number to cancel this one here. With the 6 over 9, the 3 goes here, 2. And then the 3 also goes here, 3. Good. So our fraction here, it has reduced to 2 over 3, which is equal to k over 6. Good. Now with this, then that we can do our cross multiplication, okay? Which means that the numerator of this side will multiply the denominator of the other side. And then the denominator of this side to multiply the numerator of this side. Okay, good. So we have 2. We have 2 multiplying 6. It must be equal to 3 multiplying the k. Then 2 times 6, let's assume that we don't know. So you put them in a bracket. Now we have the 2 times 6. You put them in a bracket is equal to 3k. When you reach to this stage, because we wanted to find the k, and there's a number attached to the k. Sorry. There's a number attached to the k. Then you have to remove that number and make the k be free. So you divide both sides, this side and then this side here. Okay, by the number attached to the letter. The number attached to the letter here is 3. So you divide both sides by 3. So here by 3 and here by 3. This 3 will take care of this 3 here. Okay. Now, when you come to this side, 3, because of the multiplication sign being between these two numbers, you can use the 3 to cancel any one of the number, but you make sure the numbers are possible that you can cancel. But looking at this one here, 3 can never cancel the 2. But the 3 here can also cancel the 6 here 2 times. Okay, good. Then the remaining numbers in the bracket here is 2 times 2 all over 1 is equal to, now this time k is free. Okay, good. And 2 times 2 is 4 over 1 equal to k. Therefore here k equal to 4. Okay, now this is how the fraction method works. You can also use the fraction method to verify whether what you have done is in the right path. Now, per the question given here, when you have this 6 over 9 is equal to k over 6. This time you have found the k, so it will be 6 over 9 here equal to 4 over 6. Then you try to reduce the fractions to its simplest form and check. Now, 3 goes here, 2, and 3 also goes here, 3. Then when you come to this side, 2 goes here, 2, and 2 also cancels 6, 3. Therefore, we have 2 over 3 on this side, which is equal to 2 over 3 on the other side. Therefore, these two ratios or these two fractions here are the same. Okay, good. Now, let's solve one more examples under finding the missing number in an equal ratio. Find the variable in the equation or the questions below. Now, sometimes the question must be set in the fraction form. It's not always that the question will be in the ratio form. So if you want to use the extreme method, let's solve this one. Now, extreme method. So with the extreme method, once the question is set in the what? Fraction form, then the n over 5 here equal to 9 over 15. Then you change these to ratio, okay? And then you change this fraction to ratio before you can use what? The extreme what method, okay? So let's try and write the ratio for n over 5. The ratio is n here to 5. Okay, must be equal to 9 to 15. Okay, then before you can multiply the extreme numbers and multiply the middle numbers, or multiply the middle numbers and equate it by the extreme numbers, check the other ratio whether you can reduce to its minimum or simplest form, so that it can also reduce the burden of multiplication. So with this, the other side of the ratio here can also be reduced. So the 15 and 9, 3 goes here, 3, 2. Then 3 goes here, 5. Okay, which is equal to the n to 5. Okay, we have reduced the ratio of 9 to 15 to 3 to 5. Then here you just multiply the extreme numbers. The extreme numbers are the numbers at the ends, okay? And then you equate it by the multiplication of the middle numbers here. The extreme numbers here is n times 5, which is equal to the middle numbers 5 times 3. Okay, therefore n times 5 is 5n. Okay, which is equal to 5 times 3. Let's assume that we don't know, so you put them in a bracket, which is 5 times 3 in a bracket. Okay, good. Because we want to find letter n, not 5n. So you divide both sides here by the number attached to the letter, so that the letter will be free. So the number attached to the letter here is 5. You divide both sides by 5, and here too is 5. Then you do your cancellation. This 5 here will take care of this 5. Now n is free. When you come to the other side, because of the multiplication sign between these two numbers, you can use the 5 to cancel any of the numbers, but you make sure that the numbers, they have the same common factor. So here, when you use the 5 to cancel 3, it can't be possible. There's no way you can cancel the 3 and the 5, but 5 can cancel the 5 here. So 5 goes here, 1, and 5 goes here, 1. Okay, good. Now, the numbers remaining in the bracket here. Now we have n being free here is equal to 1 in a bracket times 3 in a bracket here, all over the remaining one here. Okay, good. Let me continue from this side. Therefore, n is equal to 1 times 3 is 3 here over 1, and n is equal to 3. Okay, good. With this, if you want to confirm whether what you have done is correct, then you have to do the substitution into the question, and then replace the 3 by the n, and then you solve. Okay, good. Now let's verify our answers here, which is not part of the question. So here the n equal to, or n over 5 here and then equal to 9 over what? 15. Then you do the substitution here with 3 over 5 equal to 9 over 5 over 15 right there. Then you have to reduce these fractions here, but you check the 3 over 5 is already in its simplest form. Then you check the other side. 3 goes here, 3, 3 goes here, 5. Now we have 3 over 5 here is equal to 3 over 5 here. Okay, good. So you can see that the fractions here are the same. The same thing when you change them to ratio, it can also be written as 3 to 5 is equal to 3 to 5. Three to 5 here. Okay, good. See that the two ratios here are the same. Okay, good. Let's try and use the fraction method to solve this one. Good. The fraction method, the question is n over 5 equal to 9 over 15. Now the question is already in fraction, so there's no need to change to fraction again. When it was written in ratio, then that you're going to change to fraction, but here it's already in fraction. So the only thing that you do here, you check the other fractions and reduce it to its simplest form. And the other fractions here is 9 and 15. So here 3 goes here, 3 goes here, 5. Okay, good. So our new question will be n over 5 equal to, this time not 9 over 15, but 3 over 5. Okay, then you do your cross multiplication, where the numerator of the other side will multiply the denominator of the other side, and then must be equal to the multiplication of the denominator of this side against the numerator of this side. So our question here, to get our linear equation, the n will be used to multiply the 5 at the denominator of the other side, and you equate it by the 5 of the denominator of the first side to multiply the 3 as a numerator of the second side here. Then n times 5 is 5n. Okay, equal to, let us assume that the 5 times 3 we don't know, so you put them in a bracket. 5 times 3 here. Okay, because we wanted to find the n, not 5, so you must always divide both sides here by the number attached to the letter, which is the 5. Okay, so here 2 by 5. Then this 5 will take care of this 5, okay? So that n will be free. Then when you come here, 5 can never cancel the 3, but can also cancel this 5 here, 1. Okay, good. Now, n is free now, so n is equal to the remaining numbers in the bracket is 1 times 3 here. Okay, good. All over 1, and therefore n is equal to 3 over 1. Now n is equal to 3 here. Okay, good. So always when you're using the fraction method, you check the other fraction. It's very important. You check the other fractions and then you try as much to reduce the other fraction to its simplest form, if only it's possible that you can reduce. Okay, and yes, I want the simplest fraction. I will also cancel. Yes, I do a very hard one. Okay, then let's also do our substitution and check whether what we have done here is correct. Now we have, the question was set as n over 5 here equal to 9 over 15. Now we have found the n, so n is 3 here, so 3 over 5 is equal to 9 over 15. You can do this one aside your workings, okay? It's not part of the workings, so you do this to double check yourself. What you have done is absolutely correct, okay? Now here you do the cancellation, but 3 over 5 is already in its simplest form. There's no way you can get a number to cancel 3 and at the same time 5. But you can also get a number to cancel the 9 here 3 and the 15 here 5. Okay, good. Now our fractions here is 3 over 5 is now equal to 3 over 5 here. Okay, good. Now the two fractions here are the same. Okay, so you can choose to use any of the methods to solve and find the missing number in the equal ratio. Okay, thank you for watching. See you later. Bye.